Design Amazon Prime Video. Hey everyone, welcome back to another Exponent System Design mock interview. My name's Kevin Wei, and on today's show, we're going to be doing a system design video with Abhishek. Abhishek, before we get started, do you want to introduce yourself to the audience real quick?
Sure, Kevin. So, hey everyone, I'm Abhishek. I hail from Bangalore, India. I have 8+ years of total experience with varied background. I've been a software engineer, a startup founder, and an engineering manager. And I've worked at multiple companies such as Walmart, Flipkart, Google currently. Overall, quite an interesting journey, and I'm quite happy to be a part of this Exponent video for today.
Excellent, great. Well, thanks for coming on today's show. And this is the question that I'd like to ask you for our system design interview today. Design Amazon Prime Video.
Sure. Okay. So I am one of the users of Amazon Prime, so I have a bit of idea of how Amazon Prime works today. For the sake of this interview, right, I try to keep the scope like to the MVP version of it. So let's start with listing down some basic functional and non-functional requirements, and let's see how we can take it forward.
Sure, sounds good.
So, so to start with, I'll just list down the question also. So Amazon Prime Video. Okay, so if you go by functional requirements, right? Requirements. So I would keep it very simple. There are two types of users that I've seen on while my interactions with Amazon Prime. The one who creates and uploads the content, and thank you so much for them. And consumers like us who consistently keeps searching and viewing videos and movies for that, right? So I'll keep the same thing. I will basically want three features out of this. One is an upload video, the other is search videos, and the third will be view videos. Okay. Now, all of these three, again, right, in terms of functional requirements, they seem very simple, but when you start designing it for multiple components, it becomes fairly tricky. So before we dive deeper, let me very quickly go into the non-functional requirements, and then we can take a pause and discuss. So from a non-functional perspective, the few most important things that I can think of are uploads should be fast, primarily because it's multi-hour videos that content creators upload here as part of movies, and it would not be a good customer experience if they have to wait hours to go ahead and upload it. The same thing applies even when you are, say, viewing the videos. There should ideally be no or minimal buffering in the YouTube videos. That means we have to streamline and improve our video rendering service quite significantly. The application should have low latency and uh, high availability, which translates to eventual consistency. The reason why I'm preferring this particular design choice is because it's fairly okay if, say, I upload a I upload a Prime video and few users are able to see it, say, after 10 minutes or after 20 minutes. But once the video is available, it should be available. We cannot have transient failures in between. And that's where I prefer going with a low latency, high availability system and compromise a little bit on the eventual consistency front. And the one last component which I would be more interested in is reliability, which means once a video has been uploaded, we should not be losing them, should not be lost. Again, this is purely from a customer facing perspective and how we go about giving the customers a seamless experience end to end. So Kevin, these are the few functional requirements and non-functional requirements that I'm thinking of approaching as a part of uh, the mock interview. If time permits, we can dive deeper into additional features, say, for example, showing the view count or adding my wish list or some other features. But for the sake of this session, I would prefer going ahead with this. Any thoughts, any feedback before we go ahead?
Yeah, yeah, this sounds good. Before we start designing, I'd like to just like dive a little bit deeper into the availability versus consistency trade-off. Can you share just a little bit more about why you're choosing to prioritize availability over consistency?
Sure thing. So if you think from a pure end user's perspective, right, I don't know when my content creators are going ahead and uploading the video. Let's say they upload a video at say 1 p.m. I would be totally fine if it starts at 1:15. The same would not be true if say I was designing it for I don't know, an IPL or a cricket World Cup match when I know the streaming has to start dead at 7:30 p.m. India time, for example. Here, because it's more from an end consumer's perspective, mostly from video, which are say movies or movie series or TV series part, a slight amount of delay would be acceptable by end users. And that's why I'm preferring availability over consistency. Just quoting the CAP theorem, which is we have to prioritize in between consistency and availability. I'm assuming that the average user base will be somewhat around 100 million active users, and this partition tolerance has to be as a part of the database system. So it it's a compromise in between. This the reason for this compromise is this.
Got it. Okay, makes sense. Yeah, let's get started with the design.
All right, sure. So I'll just list down the assumption which we just made, just to be clear. We have it documented. So I'm assuming 100 million monthly active user. All right, cool. So from a core design perspective, I would list down the two types of users that we have to start with. One will be the content creators, and the second type of users we'll have is the viewers into the system. All right. So I'll start with the following two components because I'll go sequentially. I'll go with for the first functional requirement, which is upload video, continue with it, and then go ahead with search and the other features. I hope that's fine with you, right? Like
Sure.
completing one end-to-end user journey before diving deeper into the next.
Yeah, that sounds good to help us stay organized.
Cool. So I will go ahead and draw. So there will be a upload user service, upload video service, my bad. So there will be an upload video service, which will be existent as a part of this exercise. What upload video, before diving much deeper into the detail, is supposed to do is it's supposed to receive a video from the end user and push it into the storage service. Now, because we are dealing with flat files, so we'll obviously need object storage. So I'll go ahead and bring it into the system design diagram. So we'll use an object store because we are dealing with Amazon's infrastructure. So I'll just list down S3 here, which is the prominent object store model. And we'll also have to publish the metadata, for example, the title of the video, the other created at, uploaded at, the basic metadata. So we'll also be needing a metadata DB here. Okay, so that's like the most basic. I'm not connecting the lines primarily because we have not factored in the scale right now. We have not factored in how we'll make uploads fast. But the core, just at a very high level, from a 10,000 feet level, will be their content creators interact with the video service, and the video service goes ahead and dumps the information into the object store and the metadata DB. Okay, this is the simplest path. If say I was doing it for say first 10 users or first 100 users, where I'm not worried about the scale. Now, obviously, we have made an assumption that we are looking at 100 million active users, which means I'll have to scale my upload video service to more than one cluster, which means I'll have to incorporate a load balancer into our system. So let me go ahead and do both. I'm gonna basically draw a few extra rectangles over here, just to indicate that it's a multi-server architecture, and thus I will also factor in a load balancer. The reason why I'm drawing it in between is because I will obviously be using the same load balancer from the viewer side. And let me go ahead and fix my arrow lines here. So this is the first one, and the load balancer goes ahead and talks to the upload video service. So up until now, it's fine. So there are, say, a few million users, they're trying to upload the video. And obviously not all 100 million will be uploading videos on Amazon Prime. So we can say one person in every 100 person is uploading a video. So we are still looking at 1 million users. And thus we'll use a slightly different upload, like scale algorithm or scale logistics for the upload service as compared to the view service, which I'll incorporate later on. Nonetheless, so the next question that pops up, right, which is a part of our non-functional, is how do we make it fast? Now, because the videos are, say, 2 hour long or 1 hour long, it makes sense if we split them into, say, 10-minute long videos each, and distribute it using the map reduce concept, right? So if I try to incorporate that, let me just make a little bit more room for this so that we can have, I'm going to remove these arrows, and I'm going to bring few things in between. So there will be a video splitter. This is a component that again will be scaled across multiple nodes. Okay. And what this does is it basically receives the information from the upload video service, splits the videos into multiple this, and say, because we have to maintain the track record, we'll have a queue in between. So let's call this processing queue, which just acts as a message exchanger in between these two services. Okay, and now because we have split our service, we'll also have to go ahead and aggregate it. So let's call this a video encoder service. The reason why I'm not calling it aggregator and I'm calling it encoder is because I intend to do a lot more processing than just aggregation. The reason why is, so when you're viewing videos, right, I'll just list one more functional requirement. It should be across multiple devices. What I mean by that is, it can be accessed by the end user on a phone, mobile phone, tablet, laptop. You can't assume that, right? So even if we take two different devices or the bandwidth that a user has, we'll have to basically store the same video in multiple formats and multiple resolutions. All that will be taken care of by our beloved video encoder. Okay, and obviously this encoder will dump all that information in the object store. And because we have this upload video service wherein we'll store the information about the video metadata, it can directly go ahead and publish it into the metadata database. Okay, so I think this is at a very high level, a quick gist about our upload path. I will take a pause here before we dive deeper into the other sections and check in with you if you want me to specifically dive deeper into some component with respect to the upload feature. What we have covered up until now is upload video, uploads should be fast, and the basics of low latency in terms of doing an upload service.
Cool. Yeah, thanks for that quick recap also. And I love the way that you organize this into like starting with like the naive solution and then how you'd optimize it even more with like the video splitter and the processing queue and the encoder. How are the videos going to be stored? Are they all just going to be stored in S3, or are you going to do any partitioning?
We'll definitely do the partitioning. I was thinking of talking about it slightly later, but
Okay.
so
Sure. We can talk about it later. Would you like to move on to like the next functional requirement?
okay. So
Okay.
I'll just take like 5 to 10 seconds to just this. The reason why I'm parking this discussion is because the video uploaders, we say a video which is uploaded in the US will also be accessed by someone in India and someone in Australia. And this will obviously have to bring them a bit closer. So we'll not just have to do partition, we'll also have to do replication to a closer data center. But I'll talk more about this once we do the view component of it so that I can briefly touch on this.
Sure, sounds good.
So cool. Going to the next thing, and again, I'll prefer going at how a user will interact. So once a video is uploaded, the next thing that a person will do is, from a viewer's perspective, I'll come into Amazon Prime and I'll try to search for a video. That's my next component. Okay, so let's go ahead and bring that component in. So we'll have a simple search service. And without making things complex, because search is a basic feature, and I'm in the interest of time, what I'll do is I'll just use an Elasticsearch video API at the back end, which will interact. Now, how will a customer search for videos? Is basically they'll be searching it by the title of the movie that they're looking at. And that's an assumption I'm making. So let me know if you want me to search by some other thing. But considering that I'm a user, I've always typed the name of the movie or the TV series that I'm planning to watch and go ahead. So it's safe to say that the search API will be talking heavily to the metadata database and not so much to the file store, because its job is just to return the name of the movie, the title, the thumbnail at the maximum. And if you're trying to show some other additional features in the future, for example, a preview clip or something else. Okay, for the scope of this, we'll be talking heavily just to the metadata database and returning a response all the way back to the viewer who invoked the query on the load balancer set. Okay, So this is all that we'll do on the search side. How we are going ahead and implementing the search, we can dive deeper if time permits later on how the metadata will be stored in the database. It's a simple videos table, and we can discuss that if time permits. But I want to jump into the view video section if you're okay with it, primarily because that's also very interesting. That's where half the latency and availability compromise will come into picture. So,
Yeah, let's dive into view videos.
all right, sure. Thanks. Okay, so now going into the last part, right, which is this. The I call this as the view video service. Okay, and so here, there's one very important thing to note. The number of viewers on Amazon Prime is always exponentially larger than the number of uploaders. It's basically a read-heavy service. And thus the scale component, which I even forgot to incorporate in the search. So let's just say because it's a read-heavy component, we'll have say a lot more people searching for videos than the number of people uploading, and thus I'm increasing the number of boxes just to show that I'm scaling it slightly more than my upload service. The view video part, right? That will be a very critical service to the entire architecture, and thus I would definitely want to like scale it to n times more. The n value of n depends on how many number of users there are in the system at any point of time, and it will obviously be an auto scale system architecture, so not heavily going into this Kubernetes part of it. Okay, so the view video service will scale it a lot because even if we go with the initial assumption 1 million people are uploading the videos, 100 million people are consuming it, we are looking at a 1:100 scale factor in between the upload and the view service. Uh, Now comes the interesting part, right? So if you're talking about how do you store the files, we'll store it into some central repository. I would not want to wait for the first API hit wherein I push the data into my cache. We'll have a CDN and a cache both just to render the data in the right format. So the CDN will, and I'll explain to you how I intend to use both of them. But if I'm say interacting with cache or the metadata DB, the mode of interaction will be when the viewer files a request to the load balancer. I'm not drawing this arrow because I already have it. I want to keep the design slightly simple. Okay, the load balancer will send a request to the view video service. Just 1 second. So to the view video service. The view video service will first of all check if that information is already available in the cache, because we are looking at a multi-hundred million user component. I don't want to hit and overload the database in general. If it is not there, if the metadata is not available in the database, then we'll fetch it, store it into the cache, and render the video response. Here, it's slightly okay if we go ahead with, say, the pull-based cache mechanism, because it's a search feature. Search can have a bit of a latency issue. It's if you return the response in say 10 milliseconds or 20 milliseconds instead of say as close to real time. Unfortunately for Amazon Prime or any other video rendering service, that same availability parameters don't hold true when you're streaming it. Nobody likes to have a buffering video. So what we can do is when we are designing our cache CDN, which will be used for exchanging the file information, I would want to use a push-based mechanism from the object store all the way to the CDN. Okay, can try drawing a line. The line will be very badly cluttered, though, primarily because it's too far off.
No worries. Yeah.
Yeah, the core just is I don't want the end user to wait for me to fetch, say, a 5 GB file into cache for the first hit, because every single user matters. If I can do a push-based CDN, because again, the number of for a Prime, the number of users who are uploading the videos and the number of times a movie gets uploaded is not as high a frequent application as it would be for Instagram Reels or YouTube videos or something else. So I change it to a push-based mechanism. As soon as there is a new video uploaded, I want to cache it into the closer to all the geographical servers. And then the viewers will directly interact with this. I don't, from a scale perspective, I don't want the viewer to go from viewer to load balancer to view video service, just to be able to stream the video, because we are looking at very low latencies and this. This does increase our system cost because obviously we are looking at a very heavy file storage service or a CDN component here. But then that's a trade-off that I'm willing to make, primarily because I'm trying to reduce the no buffer criteria that we agreed upon as a part of our non-functional requirement, and also high availability. Okay. Uh, this is where the trade-off, right? The non-functional point number 4, high availability and eventual consistency, becomes clear because I'm pushing my videos from the object store to the cache. Now the question comes is, when do I push? If I push it during peak hours or during this, I will be throttling my network on my own, increasing the network congestion. So maybe I would want to do it at a off-peak hour, say when my user active count is slightly low, or at say scheduled intervals of every few hours. Okay, that will help me have a good balance. But that also means that a video which may be say available in the US at say 6 a.m. in the morning may be available in Australia at say 8:30 a.m. because I'm waiting for the traffic offload to happen and some other components. And that's where the high availability, eventual consistency trade-off was critical for me to go ahead with. Okay. So I know we are pretty much on time from where we started. It's if I just take a quick look at the clock. I'll pause here. We can maybe circle back, review some of the components, take some time to answer any questions which I maybe have sped through in my design, and dive deeper accordingly.
Yeah, sure. I love the way you organized this, Abhishek, and I thought it was very, very clear to me, and I was able to follow along the entire time. So I think this is a very valuable video for the audience. And before we wrap things up, I did want to ask one question. Let's say that Amazon Prime just released a very hot, very trending video that a lot of people are going to log on and try to watch. So can you walk me through the user journey here and maybe tell me if you're going to strategically add any new services or components or caching to support this very hot and very trending video that's just going to be uploaded?
Sure thing. So I'm a big Game of Thrones fan, right? And I'm watching House of the Dragons right now as we speak. Uh, there are times when, like, as a hardcore fan, I literally wait for the clock to hit that launch time and then just try pinging it. And that's exactly the case which we are there. I would not change the design much, Kevin. What I would do is when I'm doing the peak off peak hour CDN push, right, I would want to have a control over manually publishing, like, or basically force publishing a few I know which are going to be super hit titles. I know this increases a bit of onus on the product managers or the service owner side, that they have to be cognizant of the demand that we're expecting. But we should have, because we're doing a push based, it's totally depends on us on how do we want to define the push frequency for it to happen. Most of the cache services offer the ability of force push reset by setting the retry, the refresh cycle to a very low number. Any cache information that you store gets refreshed every now and then, depending on the time to live that you specify. So for critical video launches or critical days or during the holiday period, I can do two approaches. I can do a force push from my side, or I can set the cache TTL to very low, which does not require significant code changes into the system architecture. But yes, that will be a very good feature to incorporate specifically from Prime hot videos, which will be very actively used by the end users.
Cool. Great. Thanks, Abhishek. So I think this was a really, really good mock interview that we did here. I love how your communication was very clear throughout the video. I love your your drawings, and your structure was very clear for me to focus on. Like, you were able to write out like the function requirements, uploading, searching, and viewing, and you took pauses between each one to see if I had any questions. I really appreciated that, and you're able to anticipate some risks and talk about how you mitigate them throughout your design. So I thought that was very good. And before we end the video, did you have any tips for the audience on how they might want to approach a similar question if they face this in an interview?
Sure. So based on multiple previous experiences that I have through mock interviews and previous experience, uh, I have noticed people trying to overdo a lot of things when they try to do, and it's normal. We are trying to impress the interviewer, no questions asked. But in the attempt to trying to overdo, right, we either go chaotic or we are all scattered all over the place, and none of that is desirable. Okay, that takes away the freedom of taking brief pauses and say every once you complete one end of the user journey. So regular advice that I give, right, is plot like decide on the functional requirements, the way like upload, search, and this. Try to complete one of them. In that case, even if say you run out of time, you have completed say 2 out of the 3 features. It gives the interviewer a good opportunity to assess you on the completed journeys rather than saying you are jumping back and forth in between exercises. It's okay to miss a few assumptions. I missed out, for example, listing that I will be viewing videos across multiple devices when I initially chalked it up. When I started talking about it, it made absolute sense. It's okay to go back and refine a few things here and there. But what's important is to take pauses in between to think. It not just helps the interviewer catch up, it also helps you allow some extra time to think about how you want to structure your thoughts further ahead. And the other thing which I've seen, right, is people start designing directly for 100 million users. When you try doing this, you may end up making mistakes. Trust me, even for amazing products like Amazon Prime, Netflix, Facebook, they also scale their architecture with time, right? So why do the same mistake when we are doing the system design interview, in which I'm by default nervous because I'm the one being interviewed and judged? It helps to gather your thoughts, take it up. I could have brought in the load balancer a lot sooner, but I would have cluttered my thoughts if I went ahead and incorporated that. So those are the only 2 things. I prefer going slow and complete one journey after the other before actually picking the next requirement.
Nice. I think those are very great tips. And for the audience watching at home, this concludes our video. Good luck with your upcoming system design interview. And for more mock interviews, feel free to check out tryexponent.com.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.